Hello and welcome. In the previous session, we made some triangles and got that all on the screen. I'm pretty happy with that session. As a refresher, this is what we had. There we go. We've got two triangles covering the screen as a quad. Okay, now in this session, what I want to do is apply texture to this. So let's go for it. We'll break it down into small parts, keep it light and fancy free. And yeah, but to start with, what we are going to need is some images. So I'll just make a new folder, call this img for image, and let me just go online, and we're going to look for images of Marika Matsumoto. For no particular reason, it's just a thing. It was an old joke that I used to simp for, but I don't think anyone thought that was funny except for me. Anyway. Here we go. Here's a pretty cool image. Let's just go save that. There we go. Just save it as marikamatsumoto.jpg. Excellent. Done. Perfect. Okay, so I've got that. We want to load that in. But then the next thing we need is we need a library to load images. No way am I writing one of those from scratch. The famous library is STB image. Now, I know that S is Sean, I know that B is Barrett. I like to imagine that the guy calls himself Sean the Barrett, but it probably is not as silly as that. But anyway, STB image is a header-only library. So all you need is this header file, and it will load things. So I'll just go ahead and download that. I actually downloaded this already, totally fine. Just grab stbimage.h. and we'll just paste that into our source folder. Okay, cool. So there is one thing that comes with having a header-only library, and that is basically that headers can be included from all different sorts of places. And to combat that, stbimage.h has a sort of an internal guard. And that is, we can actually see that if we open up this stbimage.h, it says we need to define stb image implementation. And the reason for that is to avoid the situation where stb image is continually redefined. We can include it in as many places as we want, but we should only define that implementation at one point. And what I like to do is make just a dummy file. So if we look here, it has basically, this is how we should use it. So what I'll do is I'll just copy those lines, and then I will make a source file. I'll call that config.cpp. My approach is I like to, it may not be great, but I sort of like to have a central point where most of the libraries are included. That's in the config, but then some of it may also need to be defined. So another common example is if I want to define any string operating functions like splitting lines and stuff, I would include those, like define them in the CPP file. If I want to make any like random number generators or anything, I'd define them at one point in the CPP file, and it's the same thing with this STB image. Okay, so at this point we should have this loaded up. Now I'll save all, I was going to do some CMake stuff, but I'll save that for later, because what we also need to do is make a basic class for materials. So let's go ahead, we'll make a material header file, and we'll just go ahead and define a bunch of things. Okay, so these three functions that I've defined, we have basically the constructor, takes a file name, loads that up. We have the destructor, and a function we can call at any point just to arm the material, get it ready for drawing. Okay, what we're also going to have is a handle to the, basically the OpenGL texture. So you may remember from the previous session where we did VBOs and VAOs that basically all OpenGL assets are created on the GPU and they live there, but then we get back a handle to them, which is, it's an unsigned HDMI is playing up. What was I saying? It's an unsigned integer. It's just like an ID number. Okay, cool. So we've got that. Let's go ahead and actually define all of this. So I'm actually going to do the easier bits first, the simpler bits first. And what I mean by that is that I'm going to leave the initialization to the last. I'm going to do everything else first. Okay, cool. So first thing I'm going to do is I'm going to use the texture. So how do we use the texture? Imagine that we have created a two-dimensional texture, and there it is. We have the handle to it. What I want to do is bind that. So I'll simply go GL, and we'll have the target that we're binding to, and we will have the handle or the ID number that we're binding. So texture number 3, texture number 12, who cares? Cool, okay. Now, the next part is the destructor. So textures, so we can actually delete, we can have many textures and delete a whole bunch of them at once, but here I'm just gonna have the one. So the first argument here is the number of textures that we're deleting. The next argument is a pointer to the beginning of that array or that set. In this case, we only have one, so we just do a pointer to the original texture. Okay, excellent. Now, finally, we'll get to the constructor. So what I'll do is, first of all, I'll load the data from the file. Now, there's a little bit involved here. Okay, cool. So let me break this down. We're calling stbi load, which will take in a file name and basically load the file, and it will populate an array of bytes or unsigned characters, and it will return a pointer to that array. Because as you may know, an array is a whole chunk of memory, and it's usually referenced by a pointer to its first element. So that's what data is doing. Data is the array of unsigned bytes. But in addition to that, the procedure will also give us the width, height, and the number of channels. And the way, because this is a C-style library, the way it gets around that is it takes pointers to these arguments and it populates the variables. So here we define, okay, we want to get this info, and then this function will take those pointers, fill in the variables. Okay, great. Now this last argument here is just an argument to say, hey, I want this thing to be loaded RGBA. Even if the original file just has one channel, even if it has 3 channels, it will always be populated with 4 channels. Now this is a big deal because in some of my previous development stuff, it was really a nightmare to deal with image files that had different numbers of channels. Even though this uses a little bit more memory than we may need, it at least standardizes it. So makes it good, I would say, easy to use. All right, so the texture is loaded. Okay, great. Next thing I want to do is I want to basically make the texture. What I mean is the image is loaded. We want to make the OpenGL texture. So we'll do this. We'll go GL create textures, and again we can actually create a whole bunch of them, but I'll just make one. Yep, so I'll make a 2D texture, we'll make one of them, and we will fill in, get the handle to the created texture. We're also going to need to bind it so that we can work with it. Okay, great. Now we've loaded in this data from the image on the disk. Now we want to upload it to the graphics card, basically. And the way this works is we go GL text image 2D. Okay. Now this function has a whole lot of arguments. As a matter of fact, it's a great exercise to bring it up and have a look at it. Yep, GL text image 2D. There's heaps of variants of this, but I'm going to go with this one here. So we have target, level, format, and all sorts of things. Now, here is how I like to remember this. Okay, so target is just like everything has a target. It's a GL, vertex buffer, whatever. It's going to be GL texture 2D, no problem. These bits here, level, internal format, width, and height, and I guess border, are describing the layout on the GPU internally. So how are we going to store this stuff? And then this stuff here, these last three, are defining the sort of data that's coming in. Okay, so I think of it as like, this is how we're going to store it. This is what we're getting. I'll go through that. Okay, so target. Yep, texture 2D. And then we have level, that's the mipmap level. 0 is the base mipmap level. I'm not sure if I said this previously, but a mipmap, if you're unfamiliar, is basically repeatedly downsampling the image to smaller and smaller copies so that when the image is further away, the graphics card can select the appropriate downsampled image, and that reduces what's called oversampling or aliasing, where you get ugly visual artifacts because the texture that you're loading is really too big for where it's being drawn on screen. Okay, but anyway, internal format will be RGBA. Going to have all 4 channels, and then the width, height. This next one is the border. Now that's a border color. 0 pretty much universally represents black, so we'll just do that. And then we have the file format. Remember, this next line is going to be the stuff describing the file that we're getting in. So this has been loaded with 4 channels, and it's unsigned byte. See, we had here unsigned characters, basically unsigned byte data. And then we have the pointer to the memory location where the data is, which in this case is just data. Okay, great. So theoretically, that should all be loaded in, good to go. And we can just, just free that data because it's there on the GPU. Excellent. Okay, so I'll just get this out of the way. That is looking pretty good. Now we'll go back to the CMake and just add those files to the project. Okay, so we've got the config. Now we've also got that, that CPP. We have main, glad, triangle mesh, and we'll also include. Okay, excellent. Now let's go into the main file and get this stuff working. So I'll go, all right up the top. Yep, include material. And then, again, I'll just get this out of the way, minimize all this. Okay, so down here, we've made a triangle mesh, and then you can see that we're drawing it here. So what I want to do is say, alrighty, I'm going to make a new material. The location for that file is images, just like that. I hope I got that right. And remember that there may be, adjust this to your needs. Maybe you want to put that image folder in your build folder and then just link directly to it without this sort of indirection or something. Totally balls in your court. All right, so we've loaded that in. Now, go material, use. All right, so again, hopefully this makes sense. We're going to use the shader, use the material, draw the triangle. Okay, let's just give this a go. We shouldn't see anything, but we might get some errors. Yeah, we totally did. Okay, what have we done here? Too few arguments. Okay. Oh yeah, okay. Yep, no worries. Of course, we want to bind that as the 2D texture that we're working with. All right, give that a go. There we go. Excellent. We're not seeing anything yet, but we're not getting any errors. So I think it's fair to assume that the data has been correctly loaded. Who knows? All right. Okay, so at this point, we have loaded that file in, and it's sitting in memory, in the texture, in the GPU. The next thing is that a texture is actually not just the image data. It's also something called a sampler. Now, a sampler is a little configurable program that gives you a color when you give it a texture coordinate. In OpenGL, textures and samplers are pretty much bound together. In Vulkan, there's something called a combined image sampler, which does the same thing. It's all together, but I'm getting ahead of myself. So what we basically need to do is configure a few options. And the way we do this is there's a function called GL text parameter, and it's text parameter I because we're setting an integer code. So first up we have the target, the 2D texture, and then we have the option name, and then we have the value for that. So let's say, for instance, that when we draw the texture, we want it to repeat. If we go, so texture coordinates, I'll talk about this later, but they're basically in the range 0 to 1. But then when we go outside of that range, either end, we have what's called a wrapping operation. So I'll go GL, let's go texture wrap S. And what I want to do is just repeat. There are other options like clamping to the border, clamping to the edge or something. I just want to repeat. Okay. And now we'll do the same thing. If we were to wrap in the T coordinate, it's common to see UV for texture coordinates. OpenGL uses S and T. Then we have filters, minifying and magnifying filters. So a minifying filter will basically, okay, very rarely, almost never, will you load an image in at a certain size and also draw it at that same size. It's more common to either shrink it down or blow it up. So a minifying filter is saying, how do we sample when the image is shrunk down? And what I like to do is I like to use nearest neighbor interpolation, which is basically no interpolation for shrinking down. And I like to use linear interpolation, or in other words, just a first order approximation for blowing up. When we get the texture on the screen, we can have a look at what those options look like. But yeah, okay, so let's double checking my own stuff. Nope, I'm happy with that. So at this point, the sampler is configured. Excellent. Okay, so we've got our sampler configured, we've made our texture, we're sending it through and everything, but if we were to draw it right now, of course, we would see nothing. Just because the data's there doesn't mean the shader's using it. So let's go over to our shader program, and I guess we'll start with the vertex. So remember, with shaders, it really helps to think about the flow. Whoops. I think it really helps to think about the flow of data. So if we look over here, we're outputting some stuff and we're taking it in on the fragment side. So I'll say, all right, I also want to output the texture coordinates. That'll be a vec2. There we go. And I can be a little less precise with this because I am repeating anyway if I go outside of the range. So what I'll do is I won't create a new attribute in the mesh because the coordinates are already going to cover the screen. So if I just take the XY position on the screen, I'll take that as my texture coordinates. So I'll say, okay, fragment texture coordinate is, if I go vertex pos. Now remember, vertex pos is a vec3. The first two coordinates of it, first two elements, will be the XY. So we can actually do this. This is called swizzling when you select just a few elements of something. Great. Okay, so on the other end, I will now take that in. And over here, I will go... Now what am I thinking? I'm missing something, aren't I? Okay, yeah, so we also need the sampler. So I'll go uniform, sampler 2D, and I'll call this material. Now remember, when I say sampler, that is actually the texture data plus the sampler. It's a combined image sampler. Anyway, so in order to get something from this, we call a function called texture, and it takes two arguments. It takes the sampler that we want to sample from, and it takes the texture coordinate. So fingers crossed, this should be working. So I'll go ahead and run it. Oh, that's not great. Okay, so it's a fundamental rule. It's sort of like a conservation of energy rule, one of those universal things, that the sillier an error is, the longer it persists in code. What I've done right here is I have loaded in the image, and I'm just printing out the image size to verify that it's correct. If we run this, it's printing out 0, which is a great indicator that the texture's not being correctly loaded. Now, if we can get rid of this, I reckon. If we go back to the main and compare this image file name with this image file name, it's all spelt correctly except for the file extension. Let's give this a go. There we go. Excellent. So the texture's loaded. Now you may note that this is a little off. So there's a few things happening. One thing is, of course, the texture is repeating. So we can actually fix that by going to the shader and halving the texture coordinates. See what that does. Little better. It's still sort of repeating. Now remember the way screen coordinates go. Here we have -1, here we have +1. Okay, but the way texture coordinates go is it's still left to right, so texture coordinates actually go 0 to 1. And then down here we have -1, +1, but in texture coordinates it's 0 to 1. So it's the same convention, top to bottom, left to right, whatever, same convention. It's just that the numbers are different. So what we can do is if we take this and we add on an offset of, then if we just do some quick back of the napkin math, that -1 will become 0, the +1 will become 2, but then it'll get halved. So there we have it. It's almost correct. If we were to compare this to the original image, horizontally it would be the same, but vertically we need to flip it. And this comes down to the common convention with images is that 0 is actually the top of the image in a lot of programs. But then when we load this, now 0 is the bottom of the image. And so I don't know what to say. It's just flipped around. We can totally fix that. What we can do is we can multiply each component individually. So even though in math you can't multiply vectors like this, you totally can in OpenGL. It just does an element-wise multiplication. So the x-coordinate gets halved, the y-coordinate gets halved and flipped around. Yeah, perfect. Okay, cool. So we've got our image. Okay, so another really common thing in OpenGL programming is to actually have multiple textures loaded in. We can do that. I mean, a texture, all it does is store a whole bunch of info. We can sample from it. We can have multiple of those. For instance, if we're doing a environmental mapping, we wanted reflections, or maybe if we wanted like normal mapping or something like that. So as an example here, let's put a vignette around our image. And what we'll do is we'll set the transparency according to that. So I think I think this one looks pretty good. We can just save the image, and I'm going to call it oh, why is that not? Yeah, mask. Okay, great. So what I'll do is I'll define this in the texture and we'll work out from there. So we have this material. We're also going to have another sampler called a mask. And what we'll do is, oh, I just remembered I didn't talk about things. I'll talk about that in a second. Now I'll talk about that now, super quickly. So what I'll do is I'll just zoom in super close. I'm just going to talk about the min and max filters. So if we were to run this right now, ooh, it's not good. There we go. Okay, now we're nicely zoomed in. By the way, this still is from a show called Yokai Sharehouse. It means Monster Sharehouse, and that resonates with me because I've been in a few of those. But anyway, so what I wanted to look at is the difference between linear filtering and nearest filtering. So if I swap this out, we're zoomed in, going to do a nearest filter. Okay, so just by a bit of experimentation, we've gotten some sort of stuff. So I'm not sure how well this is coming through, but if we look at the boundary here, you might find that it's very pixelated. We can change that. Like I said, we're zooming in by decreasing the texture coordinates. It's filling up the screen. So we can go back to the material and set this to linear, and what we'll find is that the image will hopefully become smoother. This is a little hard to see, but I'm going to squint at the screen right now. Yeah, it's less pixelated, and that's especially visible around the boundaries. But yeah, so let's never do that again, but that was just a quick demonstration of filtering. There we go. Okay, excellent. So back to the stuff. So what I'm going to do is I'm going to sample from both of these textures. So I'll make I'm going to call this a base color. Again, I want to swizzle out to get Vec3, RGB. Now we could do this. We could go XYZ. By the way, if you want to grab just the fourth coordinate, that's a W in this case. But just semantically, it looks a little nicer if we name this RGB. So I'll get the RGB, although they do both do the same thing. And then I want to get the alpha. So I'm going to sample from the mask. And I'm just going to grab just the red component. Okay. And then finally, to put this all together, we will construct... We'll basically stick them all together. So we'll go base color for the red, green, blue, and then the alpha. Okay. Now there's a few things I'm going to need to do. I'm going to need to modify the material so that when I draw the material, it knows which of these things it is. So I'm going to go, okay, this material here is texture unit 0. And this material here is texture unit 1. Every sampler can address a whole bunch of different textures at the one time, and the texture unit is just like a position within that, or a handle within that. Okay, so we'll go, all right, we want to use the texture, and we want to know which unit, which unit we want to use it with. So then when we go to use it, that is accomplished with this line here, GL active texture. So texture 0 is just unit 0. What we can do is actually add that number on, and it will, under the hood, the constants, the enums are set up correctly, so it'll fix that. Alrighty, so few more things we need to do. I'm going to make another material called mask and load that in. And did I remember to do this? If we go right down the bottom, no. So let's delete the materials after we're done. Excellent, cool. So we can do this. It may not work, but let's try at least. What am I thinking? I'm getting too far ahead of myself. So I need to specify that mask material is going to be unit 0. The mask is going to be unit 1. Okay, nothing happens. That's totally fine. So what we also need to do is we need to configure this to tell OpenGL which sampler is which. So we're going to say, set the texture units, and this is done with this GL uniform 1 integer, because we're going to send 1 integer to a uniform. We want to so saying, okay, in the shader, fetch the location of that material sampler. That's what we're doing. And then tell it that it is thing number 0. The thing with samplers is they are an opaque structure, which means we really can't inspect them too much. But it turns out that when we send them an integer, they know this means that it's my texture unit. Okay, great. Now we can give that a go. Okay, same as before. Now, if you're watching this and you're thinking, why are you making intentional mistakes? The reason is I like to do the code a little bit imperfectly to highlight common mistakes. So what we can do to test this is say, okay, ignore the alpha blending for now, and let's just see if we can read in the mask. So if we go and run this, it doesn't. It doesn't read it incorrectly. So it would appear that these texture units have not been set correctly. And this is super frustrating. All we need to do is make sure that we're actually using the program before we work with it, setting any options. It's annoying that we don't get an error for this, but oh, there we go. Okay, the mask has come through correctly. Great. Okay, but then the question is, now that we can correctly address the right texture, why is the alpha not being set correctly? And it's actually a separate thing. We actually need to enable alpha blending. Okay, so we'll go GL, enable blend operations, and then we also need to specify the type of blending that we're doing. For instance, I don't know, we could be adding, multiplying, whatever. What I'm going to do is we're going to set the blend function. Now, a blend operation has got 2 components. It's got the incoming, like the source fragment, basically, and the existing fragment, the destination fragment. And a blend is a linear combination. So what we need to do is set the coefficients. I'm giving a super brief explanation here, but what I want to do is I want to use the source fragments alpha as the multiplier for the incoming fragment, and I want to take best constant names ever. I want to take 1 minus the source alpha for the destination coefficient. So a really great example of this is, say we have a fragment coming in with an alpha of 10%, then we want a weighted sum, a linear combination of the source and destination. We want the final bit to be 10% of the incoming fragment plus 90% of the destination fragment, the stuff that's already there. Or if we were to reverse it, so say we've got one coming in that has 75% opacity, then we want 75% times the incoming fragment plus 25% times the destination fragment. They all have to sum to 1 in order to keep things looking right. But this should now be working correctly. So if we run this, there we go. We've got our image, and the alpha is being set so that around the edges, it's transparent and that blue background is coming through. And what's going on here? I don't know. So there we go. Yeah, what am I going to say? Thanks for watching. As always, I hope you had fun. Kept it light. If you have any questions, let me know. Otherwise, have a great one, and I'll see you again in the next one. All right, bye.
Noroi.